All right, let's talk about something huge that's happening in software development. We are moving way beyond just writing code. Seriously, this is about a fundamental shift in what it even means to be an engineer in the age of AI. And this quote, it just nails it. This is the whole transformation in a nutshell. Your value isn't just about knowing the perfect syntax for some function anymore. No, it's about designing the entire system that function lives inside. You're basically moving up the stack, from the nitty-gritty code level to the big picture architecture level.
And look, this isn't some far-off sci-fi future concept. This is happening right now. The tools are already here, and they're changing how developers work every single day. You're evolving from being a builder, laying bricks, to being the architect who designs the entire skyscraper.
So that's the big question, right? If AI agents are going to be writing more and more of the code, what's left for us to do? Well, it turns out the most creative, most interesting, and most valuable part of the job is what's left.
The answer really starts with a whole new way of thinking, called Spec-Driven Development. This is where you, the architect, get to create the master blueprint that the AI builders are going to follow to the letter. Think of it like this. There's a new division of labor. Your job is to define what needs to be built with absolute, perfect clarity. You're perfecting the requirements, the user stories, the constraints. The AI's job? It figures out how to build it. It generates all that boilerplate, all the functions, all the classes. Just think about the difference for a second. The old way, that was you manually translating an idea into code, line by painful line. The new way is about you crafting a perfect set of instructions and then letting an AI agent handle all that tedious translation work. This frees you up to think about the really important stuff, the bigger picture.
And this new workflow, it's actually a super straightforward four-step process. First, you write the spec. Second, the AI takes that and generates a technical plan. Third, it breaks that big plan down into smaller, manageable tasks. And finally, the AI gets to work and implements those tasks. It's simple, it's repeatable, and it is unbelievably powerful.
Okay, so to really see how this works in the real world, we're going to follow a story, the evolution of a simple to-do application. This isn't just about building some app. It's about watching an idea literally grow up from a tiny script into a complex, cloud-native system, all driven by these high-level specs. So, let's take a look at the journey we're about to take. We start super basic with a console app. Then we evolve it into a full-stack web application. Then we give it an AI brain. After that, we teach it to live in the cloud with Kubernetes. And finally, we turn it into a fully distributed, event-driven system. I mean, each step here is a massive leap in complexity. So phase one is where it all begins. Think of it as our single-celled organism, just a basic command line to-do app. But the key thing here, even this super simple starting point is built entirely from a spec. No manual coding allowed. That's the rule. And the tool set for this first step is so beautifully simple. We're using Python for the logic, an AI agent like Claude Code to do the actual implementation, and a tool called SpecKit Plus to help us write and manage the specifications. That's it. That's all you need to bring the initial idea to life. All right, in phase two, our little app takes this huge evolutionary jump. It moves out of the dark ages of the command line and onto the web. It gets a real user interface, and, maybe most importantly, it gets a memory, a real persistent database. So the tech stack gets a bit more serious here, but it's all standard stuff. We've got Next.js for a slick user interface, Fast API for a super fast backend, and a serverless Postgres database so we don't have to worry about managing servers. And remember, all of this still being generated from our high-level specs.
Okay, this is where it gets really, really cool. In phase 3, our application literally develops a brain. We're adding a conversational interface, which means users can manage their tasks just by talking to the app, in plain English.
So how do we pull that off? Well, we integrate some specialized AI frameworks. The OpenAI Agents SDK provides the intelligence, the smarts, and ChatKit gives us the chat interface. The key is that we're orchestrating these incredibly powerful tools through our spec, not by manually wiring them into the application. Now in phase 4, our app learns how to be self-sufficient and portable. We package it up in a container using Docker and then deploy it to a Kubernetes cluster. This is really the foundation for building modern, scalable, and resilient cloud-native applications. And the toolkit here, this is the gold standard for modern DevOps. You've got Docker for the containers, Minikube to run a Kubernetes environment on your own machine, and Helm for managing deployments. We're even using AI-assisted tools like kubectl-AI to manage the infrastructure itself. It's amazing.
All right, we have made it to the final, most advanced stage of our app's evolution. This is where it stops being just a single application and transforms into a true distributed system with lots of moving parts that all need to communicate with each other perfectly.
And that brings up a really critical question. As we add new services, say for sending notifications, or for handling recurring tasks, or for real-time updates, how do we stop our architecture from becoming a tangled, brittle mess of direct API calls?
The answer is something called an event-driven architecture, with a tool like Kafka right at its heart. See, without Kafka, all your services are tightly coupled together, which makes for a really rigid system. But with Kafka, they're decoupled. It acts like a central nervous system for your app, letting all the different parts communicate through events without even knowing about each other. This is absolutely essential for building scalable and advanced features.
And if Kafka is the nervous system, you can think of Dapper as a kind of universal adapter. Instead of your app writing code that's specific to Kafka, it just talks to Dapper's simple API. What does that mean? It means you could swap out Kafka for a totally different messaging system tomorrow, and you wouldn't have to change a single line of your application's code. It's incredibly powerful.
So let's just step back for a second. We've seen this entire evolution, from a tiny script all the way to a complex distributed system. And through all of that, what was the developer's role? It was never to just write the code. It was to architect the entire journey.
And you know what? This number right here just proves the point. In the hackathon that this project is based on, there are a total of 1,600 points up for grabs. And guess what? The vast majority of them are for system design, for AI integration, and for using these cloud-native tools correctly, not for manually writing syntax. The value is clearly and squarely in the architecture.
And this brings us to the ultimate payoff. Mastering these skills isn't just about getting a better job, it's about building and launching your own products, your own ideas. When AI is handling the heavy lifting of implementation, a single architect can now build what used to require an entire team of engineers.
So it really all boils down to this. The bottleneck is no longer how fast you can type or your deep knowledge of some specific framework syntax. The bottleneck is now your imagination and your ability to design a great system. With AI writing the code, the only question left is, what will you build?